discuss about the laws of reflections, right? So we discussed about their types as well. Those were regular and irregular reflection. But today we are going to discuss about the image formation by spherical mirrors. So let me mark here. Alright. As you can see here, the topic image formation by spherical mirror. So let me give you an example first. Let me make here. Let's think that this is a plane mirror, right? This is a plane mirror. Wait, let me make here. This is a plane mirror, and this is a real object, while the picture which will be made in the mirror will be virtual. So, what are its picture's properties? Let's see. First of all, this picture will be virtual, right? This would be virtual. Secondly, this picture is upright, right? This picture is upright. Thirdly, if you can see the height of these two pictures, like as you can see the height of this real picture and you can see the height of this virtual picture, so the height is same in both cases. So we can also see that in the mirror image the height is same as the real image. So let me write here height would be same of the virtual image as in the real image, right? So today we'll be discussing about the how image is formed in the spherical mirror. So first of all we need to know what are spherical mirrors. So let me guys tell you, as we have two types of spherical mirrors. Wait, let me reset the marker. Okay, so as we have two types of spherical mirror, so the first is concave mirror. The first is concave mirror and another is convex mirror, right? And other is convex mirror. So if I do talk about concave mirror, what it is basically, it is a reflective surface that is curved inward and away from the light source. Like how? Let me make here. This is curved inward and this is away from the luminous source or light source. So let me tell you about the convex lens now. What it is basically, it is a mirror in which reflective surface bulges towards the light source. Like for example, if light is coming from here, this is the luminous object, right, which is producing light, right? So here, this will get curved. This will get a bulge here. So what it is basically, it is a convex mirror, right? Okay, then forming an image on concave mirror, we do have four rules. Now we are going to study those four rules. So let's see. Let me scroll down. Okay, so as you can see here, I'm just going to type here the rule number one. Rule number one, which is parallel to principal axis will pass through focus or focal length after reflection, right? This is the rule number one. So let's see what it says first. Let me highlight this with the yellow highlighter. So ray parallel to the principal axis will pass through the focal or focus after reflection. So here I want to tell some things what they are representing. Actually, this is we have C, which is representing the center of curvature. This F is representing here the focal point or the focus point, and this P is the principle of axis, right? So this rule, what this rule says, right? So this rule is saying that the ray which is going parallel to the principal axis, that, like as you can see, this is the principal axis, and this is going to this direction, right? So this line or this ray is going to this direction as well, so means they both are parallel to each other. So let's see what they are saying now. Ray parallel to principal axis will pass through the focus after reflection. Like when it will go there, it will go there, right? It will hit to the surface, and where it will reflect, it will reflect through this point, through the focal point, this point. So basically this is the rule number one. Let me make here the figure so that I can make you more clear. Wait, let me make line. So here is the line. As you can see, I'm just going to plot the points. Okay, so here would be the C, which is the center of curvature. Here would be F, which is the focal point. Here is the P, which is the principle of axis, right? Okay, let me mark. Let me make concave. Okay, now I'm making concave lens. This is the concave lens, right? Now I'm just going to mention here what this is. This is P, center of curvature. This is F, which is the focal point, and this is P, which is the principle of axis, right? This is right, and this is what we have, that is concave lens or concave mirror, right? Concave mirror, right? Now what it is saying, a ray which is going parallel to the principle of axis. This is a ray which is going principal to the axis, as this is the principle of axis. This is the ray we created. Now what it will make, like when it will reflect to the surface, it will hit to the surface, it will reflect to the focal point. As you can see, this is the incident ray and this is the reflected ray, right? So this was the rule number one. Okay, so now I'm going to explain you the rule number two. Rule number two, which what says? It says ray passing through focal point will become anti-parallel to principal axis after reflection. This is anti instead of as A will come here. Okay, now basically what it is saying, let's see. Let me use highlighter. What it's saying, a ray passing through focus will become anti-parallel to the principal axis after reflection, right? So I'm just going to explain you this with the diagram. Okay, let me make here. Basically this is, we have principal axis, right? Let me make points. This we have C, which is the center of curvature. This we have F, which is the focal point of focal length. This is P, which is the principle of axis, right? Now let me make here concave mirror. This is concave mirror. Let me level here what these are here. This is C, concave, not concave but center of curvature. This is F, which is the focal point, and this is P, which is the principle of axis, right? So now what they are saying, ray passing through focused length or focal length. Wait. Let me change the color. Let me make waves. Here are the waves. A ray which is passing through focal length, when it will hit the surface, right? When it will hit the surface where this ray will reflect, then this would reflect anti-parallel to the principal space, right? Now this, we know that this is the principal axis. This is incident ray which is coming from the luminous source, light source. This is the incident ray which is hitting the surface and then reflecting back towards the, not towards but against the principle of axis. This is against, like this principle of axis is going to this direction, while this reflected ray is going against this direction, right? So this is anti-parallel. So if I do talk about this in this diagram, what they are seeing basically, if I do have a one way which is passing through this F, means focal length, when it will hit this concave mirror where it will reflect against the principle of axis, right? So this was basically rule number 2. Now let me go and explain you guys about the rule number 3. Okay, so now I'm just going to write here what rule number 3 basically says. Rule number 3. Okay, so now what the third rule is saying, let's see. Ray passing through center of curvature. Center of curvature will follow the same path back after reflection, right? So let me use highlighter here so that I can explain you guys. Ray passing through center of curvature will follow the same path back after reflection. So I'm just going to make here the diagram. This is, we have principle of axis, right? This is, we have principle of axis. This point C, this point is F, which is the focal length of focus point. This P is principle of axis, right? I am making here concave mirror. This is the concave mirror. Now I'm just going to make the rays. Wait. Now I'm going to make the rays. So what they are saying, like the ray passing through center of curvature. Wait, let me write here so that this is C, means center of curvature. This is F, which means focus point or focal length, and this we have P, which is the principle of axis, right? So now I'm just going to make the rays. They are saying a ray is there which is passing through this curvature, through the center of curvature. Let me make this more big so that this hole is concave, right? So where this will go, right? If we have passed this from the center of curvature, it will go back to the same path. As you can see the rule, right? This will go back to the same path. Ray passing through center of curvature will follow the same path back after reflection. This will follow the same path after reflection as well. So let's check this rule in the diagram. As you can see here with the pink color, this we have just made it pass through the C, through center of curvature, then it is following the same path, right? So this was basically rule number 3. Now we are going to study the rule number 4, which is the last rule for forming an image on the concave mirror, right? I'm just writing here. So rule number 4 states that the ray incident So now what they are seeing, let me use highlighter. They are seeing ray incident at pole is reflected back, making same angle with principal axis. So let me make diagram here so that I can explain you guys. Okay. So this is, we have principal axis. This line we have principal axis. I'm just going to use this for points. This is C, center of curvature. This is F, which is focal length or focus. And this is P, which is the principal of axis. So now I'm going to make the concave mirror. This is basically concave mirror, right? Now I'm just going to mention them. This is C, which is the center of curvature. This is F, which is the focal length or focus. And this is P, which is the principal of axis, right? Now I'm making rays here with blue color. Okay, let me select this. Okay, so now what they are seeing, ray incident at pole. Pole is reflected back, making same angle with principal axis. If I am making angle from here, it is going to the principal of axis, right? It is going to the principal of axis. Then again, that is going back with the same angle, right? As we have studied in our last lecture, what we have studied the law of reflection. In law of reflection, what they told us that the incident angle is always equal to the reflected angle, right? So if this incident ray is coming, so this means it will make some angle here as well. For suppose this angle is 30 degree, so this reflected ray will be making an angle as well, right? So this would be 30 degree as well. So as you can see here, this was an incident ray and this was reflected ray. So this was reflected ray and this is incident ray. When incident ray came, it hits the point, not point, but principal of axis. It reflects back with the same angle, with the 30 angle. So this is basically law of reflection, which is the fourth rule of forming an image in the concave mirror, right? Let me show you this in the figure so that it can be more clear to you. As you can see here, here isn't giving, but I'm making, right? I'm making here. If I am making a ray here and making it pass through the principal axis, it will again come back with the same angle. If there is an angle of 20 degree, means there would be angle of 20 degree as well, because we know that incident angle is always equal to the reflected angle, and this is what? This is the law of reflection. So basically these were the rules of forming an image in the concave mirror. So in next video we'll be going with the rules of forming an image in the convex mirror. Thank you.